Okay, we're going to take a look at our cat example, and I'm just going to sort of go through the basics of this particular example. Now remember that we do not have data to collect, so we're sort of minimized as to what we can say with our plan. But with our cat data, and I can just sort of bring this cat data up, we are looking at height, weight, and body weight. And the first column of our Excel spreadsheet is heart weight, so that's our explanatory variable. It goes on the x-axis. The second column on our Excel spreadsheet is our body weight, and that will go on our y-axis. And we have, in this particular case, about 98 pieces of data. That's our sample size. So we'll ask a question. That's the very first thing that we do. And so the question becomes, I wonder if there's a relationship between a cat's heart weight in grams and their body weight in kgs. So I've used the units, and I've talked about the two variables. The second thing is the plan, and in the plan you must state what your variables are. My explanatory variable is heart weight in grams, and my response variable is body weight in kgs, and that needs to reflect my variables here and my variables on the graph. I can't say very much about the plan because I'm not doing any measuring, but I have been given some cat data in an Excel spreadsheet. I create a scatter plot with heart weight on the x and body weight on the y-axis. I will draw a trend line and do investigation to see what the relationship is between the two variables. I do not know how the cats were measured, but they would obviously have to be deceased to do heart weight and so on. I do not know how they minimize variability either. So there's some questions about this because we don't know how all the data was measured, we don't know where the data came from, and so on. So we've gone through our checklist and our plan, state the variables, describe how they are measured, will be taken. We didn't do these measurings, so we don't know. Explain how the data will be collected. Well, we collected the data because it was given to us in Excel, and that's how we collected the data. Explain how resources or sources of variation will be handled. Well, we don't know. We don't know that, so we can't comment on it, and explain how results will be recorded. Well, we're going to create we've got our spreadsheet, and we're going to create a scatter plot and then do our analysis. The data, we've got a title on our graph, we've got a trend line. Now that trend line is a little too low, so we're just going to move it up a little bit, and so that's a better trend line now. And we've got axes labeled, both the x and the y axis labeled, and we've got a trend line drawn. Now we get into our analysis, and in our analysis we have to describe and justify the relationship between the two variables in context. So shape, direction, and strength. So we talk about the fact that this relationship is linear, strong. I'm going to say it's strong. Some might say it moderately strong, and positive. Okay, so that's basically the shape, the direction, and the strength. Now we have to give justifications for those. Evidence. Linear because, right? Linear because all the dots basically follow the trend line in sort of a straight, steady pattern. Steady pattern. And then what about strong? Why do you consider it to be strong? Well, I mean, some people might argue that that's moderately strong. I mean, we can draw in our little, we can draw in our little sort of parallel. Well, that's a very bad parallel line, but you get the idea here. If you want to try to include all the data as best you can, that's a very badly drawn line, but those should be parallel to the trend line, and that's not a wide band, that's not a super wide band. Most of those dots are fairly close to the line, so I'm happy to call that a pretty strong pattern. Somebody might say moderately strong because there is some scatter. Some of the points are a little bit scattered out and so on. That's fine. So you justify that. Strength, I would say strong because most of the data points are quite close to the trend line. And then direction, well, it's positive. It's positive increasing, and that's because as heart weight in grams increases, the cat's body weight in kgs also increases. Okay, so you need to give evidence for direction being positive or negative by explaining what's happening with the variables. Describe anything unusual. Well, I would say that this is probably an unusual point right here around 21 and it seems to be about 3.8. Now, if I want to find that, I could probably find that. That might be that one there on the very last dot, which seems to be the biggest one. So that seems to be that dot right there, about 20.5. Or if you said 21 and about 3.8, 3.9, that's fine. You get it off the graph. So 21 and 3.8. We know it to be about 20.5, but that's okay. That's okay. Just name it. And why is that unusual? Well, if you take a look, sort of, there's other cats with similar sort of body weights, somewhere around 3.8, 4, but they don't have nearly as big a heart, like not even close as big a heart. So this cat, the reason that it's very unusual is that for its body weight, it has a very large heart. Now why? Why is that? Well, hard to say. We don't really know for sure. Maybe it had a heart disease. That caused it to have an enlarged heart. Who knows? I mean, we're guessing and speculating here, but you can speculate, and something reasonable and that makes sense. Okay? But you explain why it's unusual. You gotta give it in context. So we've done that. So, and then we do the gradient, and then we use the trend line to make a prediction. So I'm going to skip the gradient for a moment, and we're going to do reliability. So if I just get rid of all my squiggly marks here. Now, making a prediction, let's make a prediction outside the data. So we know that, just out my trend line, don't want to do that. So let's make a prediction outside the trend line. So I'm going to go, okay, well, the last piece of data here. So if I was to extend my line and go out to say 25, all the way out here, and kind of make a prediction about what's going to happen with my trend line, it's going to be somewhere way up here. So maybe that would be, you know, it's going by 3.5, 4, 4.5, 5, 6, 7, I don't know, 8 or 9 kgs, maybe 9 kgs. You don't have to go that far out, but you get the idea. So if I was to make a prediction, say at 25, a heart weight of 25 grams, I predict, based on my model, trend line, that the cat would have body weight of 9 or 10 kgs. It's kind of a bit of a guess because I've had to extend my line a little bit, right? So is that possible? It's possible. Is it likely? Not sure if it's likely, because cats, that's pretty big for a cat. And we know that our trend line, there's limitations to our trend line, so, you know, like, I'm not very confident in that prediction. Because it's outside the data, and cats generally are not going to be that big. Right? I mean, cats have a fairly finite limit as to how big they can get. There are some very large breeds, but generally speaking, cats aren't. In a follow our pattern, cats are not going to get that big. So I'm not particularly confident in that prediction because it's outside the data. Cats are generally not that big, and so there's some limitations to my model. And you can talk about, you know, limitations at this point if you want, about, you know, the fact that this pattern of cats is not going to go on forever in a linear way, because cats just aren't going to continue to get infinitely bigger and bigger. Heart weights aren't going to continually get bigger and bigger and bigger. There's going to be a point where we're going to hit a point where it's just not possible for a cat to have that big a heart or to be that size. So you talk about limitations, and maybe you can talk about those limitations here where you've made your prediction. And we'll talk about gradient in a separate thing.